Hello friends, myself SUBHASH NAGARSE from Sri Digambar JAIN GURUKUL High School, Solapur. I shall welcome to all of you in this session of 9th Standard Mathematics Part 1st. The topic is Polynomials Part 1st. In this session, we are going to discuss with introduction to the polynomials, degree of a polynomial in one variable, degree of polynomial in more than one variable, and types of polynomials. Friends, this polynomial part 1st, it is very important topic as far as 10th standard is concerned. You are in the 9th standard, so you should have to recall the things that you have already learned in the previous standards related to this topic. That will prove the base for learning the content of this chapter. In this chapter, we are going to discuss with the following important subtopics. That is introduction to the polynomials, degree of the polynomials, value of the polynomial, then operations on polynomials, synthetic division method, remainder theorem. Today in this session we are going to discuss with introduction to the polynomials. Friends, let us start with introduction to the polynomials. Polynomials, poly means many, plus nomials, that means terms. Thus, a polynomial contains many terms. Thus, a type of the algebraic expression with many terms having variables and coefficient is called a polynomial. The meaning of this polynomial is associated expression that has several terms. It is defined as a single term or a sum of the finite number of terms. Polynomial can be operated for addition, subtraction, multiplication and non-negative number exponents, that is powers. Is either a single number or a variable, or numbers and a variable multiplied together. Terms are separated by plus or minus sign. For example, 8x plus 7 is equal to 5. Variable. An alphabet used to denote a number. For example, 8x plus 7 is equal to 5, where x is a variable assigned to number 8. Coefficient. A number used to multiply a variable. For example, 8x plus 7 is equal to 5, where 8 is a number and used to multiply with the variable x. So 8 could be the coefficient. Now operator. Symbols used to perform different operations, say addition and subtraction, multiplication, etc. Constants. These are the terms in the algebraic expression that contain only numbers. For example, in 8x plus 7 is equal to 5, where 7 and 5 are here coefficients. Exponents, or you may say power also. An exponent refers to the number of times a number is multiplied by itself. For example, 2 raised to 2, 3 raised to 3 and so on. Friends, now what about these things? If you have got a term 8x raised to minus 3, this is not a polynomial term. Why? Since here the variable has a negative exponent, minus 3. One more example we will consider. 1 upon m raised to 5. This is also not a polynomial term because the variable is in the denominator. Next, one more we will consider. Root of y. This is not a polynomial term because the variable is types of polynomials based on a number of terms. There are 3 terms in this polynomial, that is a monomial. Algebraic expressions with only one term is called a monomial. For example, 2x, 2, 5x, 3y, etc. Binomial. Algebraic expression with 2 terms is called a binomial. For example, 2x plus 2, 3y square plus 5, 3m plus 3 and so on. Trinomial. Algebraic expressions with 3 terms is called a trinomial. Example, 3x plus 3y plus 2, 5y square plus 2y plus 2, etc. So monomial, binomial and trinomial, these are the three types of polynomials that are based on the number of terms. You could see here in each example, for the first there is only one term, in the binomial there are two terms, and in the trinomial there are three terms. But algebraic expressions having more than two terms are collectively known as polynomials. Friends, here you can see the types of the polynomials that are based on the number of terms. First you could see 2x and 5, only one term in this polynomial, therefore it is a monomial. In the second you could see x square plus x, m square minus 3m, here two terms in the polynomial, therefore it is a binomial. Half y square minus 2y plus 5, or x cube minus root 3x square plus 5x, three terms in this polynomial, so it is a trinomial. Now let us see the next, that is degree of the polynomial in one variable. Polynomial in one variable are algebraic expressions that consist of terms in the form of ax raised to n, where n is a non-negative, that is a degree of a polynomial in one variable is the largest power, or you could say exponent, in the polynomial. While finding the degree of a polynomial, the polynomial powers of the variable should be either written in the ascending or the descending order. It is better to write in descending order. The first term will become the degree. For example, the polynomial 2x raised to 7 minus 5x plus 9 in one variable has the degree 7. The degree of any non-zero constant polynomial is always 0, and the degree of zero polynomial is not defined. This is very important. That is, the degree of any non-zero constant polynomial is 0, and the degree of the zero polynomial is not defined. Keep it in mind, this word. Now degree of the polynomial in more than one variable, that is also called as a multivariable. The highest sum of the powers of the variables in each term of the polynomial is the degree of the polynomial. For example, 3m cube n6 plus 7m square n cube minus mn is a polynomial in two variables m and n. Degree of the polynomial is 9, as the sum of the powers 3 plus 6 is equal to 9, the first term. Second term 2 plus 3 is 5, and third term is 1 plus 1 is 2. But highest power or the exponent is first term, it is 9. Therefore this polynomial has a degree 9. Now let us see the types of the polynomials that are based on a degree. You could see this tree diagram, polynomials in one variable. You could see here first 3x minus 1 and 7y. These are the polynomial having degree 1. It is a linear polynomial. Its standard form is ax plus b, where a and b are coefficients and a is not equal to 0 because a is multiplied with the variable. Now in the second, you could see 2y square plus y plus here a, b, c are the coefficients and a is not equal to 0. Since it is a quadratic one, therefore x square term should not be 0. X square coefficient should not be 0. Therefore a is not equal to 0. Now here x cube plus 3x square plus 2x plus root of 3 or m minus m cube. These have a degree 3. It is a cubic polynomial. Its standard form is ax cube plus bx square plus ax plus d. Here a, b, c and d are coefficients and a is not equal to 0. Since a is the coefficient of x cube, therefore it should not be 0 at all. Friends, now let us see the polynomial an x raised to n plus an minus 1 x raised to n minus 1 plus and dot dot plus a2 x square plus a1 x1, rather than you can write simply a1x plus a0 is a polynomial in x with a degree n. Now an minus 1 dot 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 a2 a1 a0 are the coefficients and an should not be equal to 0. So standard form of the polynomial, if p of x is equal to x minus 3x square plus 5 plus x fourth is a polynomial in x which can be written as descending powers of its variable as highest one x fourth minus 3x square plus x plus 5. This is called as the standard form of the polynomial. Now coefficient form of the polynomial. Friends, one can write the coefficient of the variables by considering all the missing terms in the standard form of the polynomial. For example, the x cube minus 3x square minus 8 can be written in the standard form as x cube minus 3x square plus 0x minus 8. In the previous written, that is x cube minus 3x square minus 2, here x term was not there, therefore you can write for that 0x. This can be written as the coefficient here in the bracket 1, minus 3, 0 and minus 8. This form of the polynomial is nothing but a coefficient form of the polynomial. Now index form of the polynomial. P of x is equal to x minus 3x square plus 5 plus x fourth is the polynomial in x. In this polynomial, there is no term having power 3 of the variable. We can write it as 0x cube. It can be added to the polynomial and it can be written as x fourth plus 0x cube minus 3x square plus x plus 5 in the descending order. This form of the polynomial is called as the index form of the polynomial. So what we have been discussed today? In this session, we have discussed on the following subtopic of this chapter, that is introduction to the polynomials, then types of the polynomials that are based on the number of terms, then a degree of the polynomial in one variable, degree of the polynomial in more than one variable, also called as a multivariable, and types of the polynomials based on the degree. So friends, prepare this theoretical part of the introduction to the polynomials. Now, you should not forget the famous words of Bo Jackson. Those are, set your goal high, set your goals high, and don't stop till you get there, and don't stop till you get there. So friends, if you like this video, please subscribe and share with your friends, and don't forget to press the bell icon in order to have notifications of the next videos. So with these words, I would like to say thank you.